In this lesson, we are going to have a look at trigonometry with respect to non-right angled triangles. And the first rule that we're going to discuss is the sine rule. Now, there's going to be a second part of this video which is going to discuss the cosine rule. Right, so let's talk about the sine rule, right? And when we're dealing with sine rule and cosine rule, the first part that I want to focus on is labeling the sides and the angles of the triangle, right? So the way we go about it is we label the angles with capital alphabet. So I've labeled this as A, B, and C. And the side opposite to angle A is going to be side A, which is all the sides are labeled with lowercase alphabets. The angles are labeled with uppercase alphabets. And obviously the sides opposite of the angles are corresponding. So side B is right opposite to angle B. Alright, and so on and so forth. Right, there's two versions of the sine formula I want to focus on. Well, it's the same formula except it's written in two different formats, right? Now, I prefer to use the first format when we are trying to find the side lengths that are missing in the non-right angled triangle, right? And I prefer to use the sine rule in this particular format if I'm trying to find the size of a missing angle. Right, so what is sine rule? Sine rule basically states that the ratio of the side length to the sine of the angle opposite to it is consistent across the three ratios, right? That's what sine rule represents. Now, let's jump into when we're going to use the sine rule. We can use the sine rule, obviously first thing, we're dealing with non-right angled triangles. We can use the sine rule when we have two angles and one opposite side. Right, or we have an angle and its opposite side and one other side. So basically a complete ratio and one other side. Right, so basically, in other words, we need three pieces of information to be able to use the sine rule. Right, so I would really strongly encourage to add these points to your reference notes. So let's jump into the example first. Right, so in this particular question, they want us to find the length of m corrected to decimal places. Right, so in this particular triangle, right, I have two angles, 35 and 70. I also have length 5.2, which is opposite to 70 degrees. So in other words, of the 2 points that we had written down when we can use the sine rule, this particular question represents what's happening in the first out point. So we have two angles and one opposite side, and we're trying to find a missing side, right? And obviously we're trying to find the side length, so I'm going to represent my ratio in this particular format. Alright, so I'm going to start with what is missing. So the side that is missing is m, so m corresponds to the angle opposite to m is 35 degrees, so m divided by sine 35 degrees is going to be my first ratio, is equal to, now the other complete ratio that I have is 5.2 and 70 degrees, so 5.2 over sine 70. Right, so to solve for m, we can multiply both sides by sine 35, so if I multiply both sides by sine 35, right, so obviously sine 35 goes into itself once, so the solution for m equals 5.2 divided by sine 70 times sine 35, right? This is what we would need our CAS calculator. So I'm going to go control divide, so 5.2 over sine 70 times by sine 35, right? And obviously please make sure your calculator is in degrees, right? Control enter gives me the length of m as 3.17 correct to two decimal places. Now, alternatively, right, obviously I want to also focus on if you don't want to do the calculation mathematically, obviously that's taken us 2 steps to get to the final answer, right? Since we have access to a graphics calculator, we could actually, when we're trying to solve for side lengths, we can use the solve function by simply directly entering this step into the calculator. So that's what I'm going to show you to do next, right? So I'm going to go menu, algebra, solve. Alright, I'm going to have my two ratios entered, so m divided by sine 35 equals 5.2 divided by sine 70. Right, and since we're solving for m, I'm going to put a comma m, control enter. That is also giving us the answer as m equals 3.17. Right, so obviously we can use the solve function. We can use the solve function if we are trying to find the length of a missing side. Right, now we can't use the solve function when it comes to angle size. Now we'll talk about this when we get to a later example. Alright, so let's jump straight to question number 2. Alright, so let's have a quick read of this question. Steel trusses are used to support the roof of a commercial building. The struts in the truss shown are each made from 0.8 meters steel lengths and are welded at contact points with the upper and lower end of the section. Right, so what they're basically they're trying to tell us is these lengths here, all of them are lengths of 0.8 meters. So the question here is asking, on the lower section of the truss, what is the distance between each pair of consecutive welds? So in other words, they're basically asking us to find what this particular distance is equal to. Alright, so if I quickly represent that triangle on the outside, right, so that's 130 degrees, that is 0.8, and that is also 0.8, right, and we are trying to find x. Right, so which is the side length missing. Right, what I also can gather from looking at this diagram is this is an example of an isosceles triangle, right? And the property of an isosceles triangle is the sides and the two angles that are opposite to the equal sides are equal in size, right? What we also know about a triangle is the fact that all angles add up to 180 degrees, right? So if one angle is 130, the remaining two angles should add up to 50. Right, and half of 50, each of this is equal to 25 degree angles, right? Obviously the angles opposite of the equal sides are equal when it comes to an isosceles triangle. So now we can set up the ratio, the sine ratio that we're dealing with, right? So we're solving for side lengths. I'm going to start with x over sine 130, right? So that's the angle opposite to x, equals 0.8, which is the given side length, divided by sine 25, right? And that's what I'm going to use in my CAS calculator to find the length between each pair of consecutive welds. Right, so going to my CAS calculator, menu algebra, solve. Alright, so x over sine 130 equals 0.8 over sine 25, control enter. Oops, I didn't curve in the command for solving for x, so comma x. Right, and now control enter gives us the length of x is 1.45 meters. So x is equal to 1.45 meters, which is the distance between each pair of consecutive welds. Right. Second part of this question, what is the height of the truss corrected to the nearest centimeter? Right, so if I go back to my diagram, they're basically asking me to work out the perpendicular height of the truss correct to the nearest centimeter. Right, so again, if I take my triangle into the perspective, right, so the perpendicular height is basically the height that runs straight in the middle, right? So we'll just call that as h, right? We know that this is 0.8, that is 0.8. This angle is 25 degrees, right? Now we are dealing with the case of a right angle triangle in this particular case, right? So if I take into account the right angle triangle, right, again, I'm just going to draw this separately for explanation purposes. H 0.8, 25, right, and I label my sides, right, and that's going to be my hypotenuse, that's going to be the opposite side, and the third one's going to be my adjacent side, right? Since we're solving for the opposite side and we have the hypotenuse, the ratio we're going to pick is the sine ratio, so sine theta equals opposite over hypotenuse, right? Obviously very important focus here, we're dealing with a right angle triangle, so we've got to go back to a knowledge of sine, cos and tan ratios, right? Not the sine rule or the cosine rule. They are meant for non-right angle triangles, right? So substituting values, so sine 25 equals, the opposite side is h, over 0.8, right, to solve for h, we can multiply both sides by 0.8. Right, 0.8 goes into itself once, right, leaving us with h equals 0.8 times sine 25. So that is going to be 0.8 times sine 25. Gives us the perpendicular height, or the height of the truss, being 0.34 meters, right? Or in other words, because the question wants us to correct to the nearest centimeter, timesing that value by 100, the nearest centimeter is going to be 34 centimeter, and that's going to be the height of the truss. Right, one last example in this topic. Right, in this triangle, we are trying to find the value of theta. Right, so, and again, if I focus on this particular triangle, I can see I have two side lengths. I also have an angle opposite to one of the sides, right? So if I go back to the dot points about the sine rule, right, that takes me to the second dot point. I need an angle and its opposite side and one other side, right, which is the case in this particular triangle. We have an angle and the opposite side and one other side. All right, that gives us, we're trying to solve for theta, right? And we're going to use the sine rule again in this second format, right? That's what I'm going to prefer when I'm trying to find the size of an angle, right? You can go ahead and use this format. It's just going to add one more step of working out for you, right? So I'm going to use the sine rule in this particular format. So I'm going to have sine theta over the side opposite to that is 9 centimeters equals sine 38, and the side opposite to that is equal to 8 centimeters. Now please make a solid point here, right? We can't solve this using the solve function in the CAS calculator, which means we need to carry out a couple of minor steps before we can actually use a CAS calculator, right? So the first step for solving for sine theta is I'm going to get rid of this 9 by multiplying both sides by 9, right? So if I multiply both sides by 9, 9 goes into itself once. I'm left with sine theta equals sine 38 over 8 times 9, right? And remember when we dealt with the right angle triangles and we tried to solve for the angle size, the way we work it out is basically sine inverse of the answer that we get in the previous step. Alright, I'm just going to rewrite the same thing just to avoid any rounding errors. Alright, so the value for theta is going to be equal. This is the way we're going to use our CAS calculators, right? So trig, I'm going to select sine inverse, right? Inside there, I'm going to enter what we had in that previous step, so sine 38 on 8 times by 9, right? I press enter. Obviously control enter would be a better option. 43.84 degrees. 43.84 degrees. Now another thing I want to emphasize here is when the question deals with finding the size of a missing angle, more often than not the question will want it correct to the nearest degree, right? So for this particular question, the value for theta correct to the nearest degree is 44 degrees, right? And that comes to the conclusion of the sine rule part of this lesson, right? Please note there will be another video on the cosine rule, right, which I strongly encourage you to watch, right? Thank you for listening, and have a wonderful day.